All right, so we're going to take a look at another example. And I have y equals negative x squared plus 2x minus 3. Well, remember in the last video, we've talked about that this negative tells us that this is actually going to be opening down. So if the a is negative, it's an opening down parabola. This is some good information just to kind of keep in the back of your mind. We're going to start with the axis of symmetry. So x equals negative b over 2a. So negative b, negative, the b value is with x, so the b value here is 2 over 2 times a. And the a value, remember this is like negative 1, so the a value is negative 1. So I have negative 2 over, well, negative 2, which equals, well, positive 1. So my axis of symmetry is x equals 1, and I'm going to show that with a little dashed line, knowing that my parabola is going to draw right around here, creating that symmetry or symmetric U. Vertex. So vertex is either the top or the bottom, and it is written as a coordinate, so x and y. Well, I know x. We've already found x, so let's go find y. So I'm going to rewrite my equation. Y equals, I have negative x squared plus 2x minus 3. So let's plug that in. So y equals negative, now here's kind of fun, 1 squared plus 2 times 1 minus 3. Just going to plug it in. That 1 is being squared. The negative needs to be out front. Remember, we could say that's like saying negative 1 times x squared. So I could rewrite that negative 1 times whatever the x value is, 1 squared. So y equals, well, negative 1 times 1 squared. Well, 1 squared is 1. 1 times 1 makes 1 times negative 1. So negative 1, 2 times 1 is 2. And I still have negative 3. So negative 1 plus 2 minus 3, y is going to equal negative 2. So I'm going to rewrite that vertex. I've got 1, negative 2. I'm going to put that on my graph. 1, negative 2. Now think it's opening down this time. So my vertex is going to be on top, or a maximum, right? I'm going to look for my y-intercept. Now remember, y-intercept is still where x equals 0. So I'm going to set that up. If 0 is here, and I'm going to input that. So y equals, well, negative 0 squared plus 2 times 0 minus 3. Again, just start thinking, if this is what's happening, that these are always going to be 0, which means it's just going to be whatever the c is. So y equals negative 3. So 0, negative 3. Let's go put this on our graph. 0, negative 3 goes here. I'm going to mirror that over to here because I know that that's symmetric. And I could kind of make a little line here, right? It would be helpful if I had some additional points to see how far it goes out. And usually we would use the solutions, but look here. We already said it's opening down, right? Solutions are roots, or solutions are x-intercepts. Will this parabola ever cross the x-axis? No, it's going the other direction. So what I would say here is this has no solutions. Or, remember, we would write that null set. There's no solution for this quadratic, because solution is about where it crosses the x, and it does not. We do still have a domain, though. It's still all real numbers. That's not changed. And we're going to look at our range. Our range is all about y, so we're going to start with y. A little different this time, because instead of going up being greater than, it's going down. It's opening in a downward. So this would be less than. It is still equal to. And it starts at negative 2. So all y values at or below -2 would meet this function. And it's at the top of the parabola, so that makes it a maximum. And the max is, well, the max is -2. So there's another example of graphing a quadratic using axis of symmetry, vertex, y-intercepts, solutions, knowing what the domain is, knowing what the range is, and relating that vertex to either being at the top as a maximum or at the bottom as a minimum.